Okay, folks, we're about 2 minutes past the hour now, so I'm going to get us started with this webinar. Hi, I am Tim Erlin, VP of Product from Wallarm, and today I have the pleasure of basically doing a product demo for you. This webinar is about smarter API security, and we'll focus primarily on Wallarm and what we're capable of. We will look at a few slides, sort of set the context a bit, talk about the threat landscape, and then dive into a product demo. A couple of housekeeping items. This is being done on both Zoom and broadcast on LinkedIn. If you have questions and you're on the Zoom, feel free to put them into the Q&A. If you have questions and you're on LinkedIn, feel free to put them into the comments. I'll do my best to address those as we go through the webinar. And if not, I'll try and get to them at the end as well. We are recording this, of course. It will be available on LinkedIn, so you can always come back and watch it on LinkedIn as well. If you're interested in recording, just let us know and we're happy to share it with you as well. So with that, we'll go ahead and get started. For those of you who aren't familiar with Wallarm, I thought it would be worthwhile to just do a really brief little bit of history about who we are and what we do. Wallarm was founded back in 2016 and came out of the Y Combinator startup incubator, if you're familiar with that. And at the time, the founders really saw this gap in the market where organizations were deploying web application firewalls to protect their web applications, but their developers were really shifting to focus on building things on top of APIs. And the web application firewalls didn't really understand the APIs, and as a consequence, there was a gap in what protection they were able to provide. And so Wallarm was really founded to fill in that gap and focus on API security because APIs are where everybody was doing all of their development or headed towards. And that trend in development has continued. Wallarm has continued to focus on API security since its founding. It's really the focus of what we do. Because we've been around for a little while, we have customers who have had our product deployed in production for a number of years, protecting their APIs as well. I want to set the context a little bit for what's happening today in terms of the threat environment and why this conversation is particularly relevant and important in the world today. I've put up on the screen two pieces of data from our API threat stats report. So we do a quarterly report where we analyze the threat environment, and then we do an annual roll-up of those quarterly reports once a year. So this is data comparing 2023 to 2024 on sort of two different axes, if you will. The first is the percentage of CISA's known exploited vulnerabilities catalog that are API related. So CISA tracks vulnerabilities that are being exploited in the wild. That's why it's called a known exploited vulnerabilities catalog. In 2023, 20% of those vulnerabilities were API related. In 2024, 50% of them were API related. So that means we saw a significant increase of 150%. And it means that through 2024, 50% of the vulnerabilities that were being exploited in the wild, as tracked by CISA, were specifically API vulnerabilities. So what that tells you is that APIs are being attacked. Perhaps even a majority of the time of those attacks are targeting APIs. The second piece of data we have up here is information about published CVEs, so published vulnerabilities, that are AI related. And I know there's only one letter difference between API and AI, so we'll try and keep those straight. So for the AI related CVEs, in 2023, there were 39 of them. In 2024, that jumped up to 439, so more than 1,000% increase. Now, those are still relatively small numbers in the grand scheme of vulnerabilities that are published in a given year, but that increase really points to not just the rise of generative AI, but the rise of vulnerabilities in AI as well. And that's an important piece of information to have. So we want to sort of combine those two things together, API vulnerabilities and AI vulnerabilities. So we looked at those AI vulnerabilities that were published in 2024, and we found that in fact 98.9% of them, so nearly 100%, were actually API vulnerabilities. And we broke that down into sort of directly API related and indirectly API related. So you can see the numbers up there, 77% were directly API related. So that's a vulnerability in an API that is an AI product or AI related product. And about 22% were indirectly related. So flaws in things like third-party integration still impacted the AI product in particular, but wasn't necessarily specifically an API vulnerability in that product's API. But regardless of which of those numbers you look at or how you break them down, the conclusion seems pretty clear that when you're talking about AI vulnerabilities, you're really mostly talking about API vulnerabilities as well. There's nearly a one-to-one, nearly a 100% overlap in API vulnerabilities and AI vulnerabilities. So that's why we say AI security is API security. You can't really do one without the other because they're so tightly connected. But that connection between the vulnerabilities isn't the only connection to make. We also see a pretty clear path towards massive growth in the number of APIs that organizations are using because of the adoption of generative AI applications and agentic AI as well. So if you think about this, it makes perfect sense. If I deploy an agent, I'm going to have users connecting to that agent. That connection is going to be some kind of an API. That agent, because it's an agent, is designed to go take some kinds of actions. Maybe it's booking a flight for me. Maybe it's changing a dinner reservation. Maybe it's updating a password. Who knows? Those connections are all going to be via APIs. So that agent is now connecting outbound to multiple APIs. That agent, of course, might connect to another agent in order to take some actions or for that other agent to take some actions. That's going to be an API connection that spawns more API connections. So you can pretty quickly visualize how the deployment of AI agents results in this sort of exponential growth of APIs within an organization. And so we see that that's how the AI market drives an API market explosion as well. So API security is not only important because it's specifically coupled to AI, but also because AI is driving an explosion in terms of the usage of APIs as well. So with that, let's talk about the API security challenges. These are the things that ultimately are going to be important in the demo that we're going to aim to show in the product itself. And we break these into really three primary challenges that we see with customers and that we're aiming to address. The first is a lack of API security posture management. This is really a visibility challenge. Most organizations don't know how many APIs they have. They don't know where those APIs are. And when you throw the AI agents or AI APIs into the mix, that makes it even more difficult. But it's not just discovery that we're talking about here. We're not just counting and inventorying. We're also talking about the risks that those APIs exhibit, what sensitive data they might be exposing or using as part of those APIs. That's what rolls up into sort of a security posture management category. In some cases, you might call this API discovery, but we like to think of it as a little bit more than that in terms of the challenge that customers have. The second challenge is runtime security. How do I detect and block attacks? Simple to say, difficult to do. So if you have APIs, they're being attacked. In fact, we did at the end of last year, we did an API honeypot report. So we deployed a honeypot, an API honeypot, in order to measure how quickly APIs were discovered and attacked in that scenario. And we found that a newly deployed API will be discovered in, I think the average was 34 seconds. The fastest was 29 seconds, basically 30 seconds. So if you're deploying a new API on the internet, it's going to be found in about 30 seconds. And that's a pretty surprising number, I think, for most folks. So detecting and blocking attacks is a huge challenge, and it's very important. Absolutely. The third one is a lack of resources, and you could think of this in sort of two ways. You know, as a security organization, you might not have enough people to run an API security program. That's challenging. Or you might have people but not have the skills to run an API security program because it's new technology or it's something you haven't done before. So that's a second resourcing challenge, if you will. And so we aim to address all three of these challenges for customers, and we'll look at how that goes in the product demo itself. With that, I'll bring up a lovely marketecture slide, which is really just a visual way for me to list out the things that Wallarm does and point out some of the ones that are most important to us. We'll try and cover most of these in the demo. Certainly, we'll cover blocking attacks, we'll cover API abuse, and we'll cover the discovery and posture management. The things that I think are important up here, first of all, we've got a few protocols listed across the top there. The support for parsing and understanding multiple API protocols is a key benefit or value that Wallarm has. We want to make sure that we address the technologies that you're using, whether it's REST, which is very common, but also things like SOAP, gRPC, GraphQL. WebSockets aren't up there, but they are supported. More and more organizations have more than one API protocol that they need to support. One other thing that I'll point out here, which is I think important, but not necessarily easy to demo, is the deployment options. It's important to us that we be able to deploy our product in your environment. If we build a great product that you can't deploy, ultimately that's not very useful for you. So we support a wide variety of deployment options for the Wallarm filtering nodes, which are what parse the traffic and look for APIs and detect and block attacks. So if you want to deploy that completely as a SaaS solution, you can do that. If you want to deploy it as a Kubernetes ingress controller, as a standalone reverse proxy, integrated with an API gateway, there are lots of different options there to support your environment. And if you have an environment that we somehow don't support, we work very hard to do that as well. So with that, we can move forward to the demo itself. So I'm going to skip out of the slides here and move over to the product user interface. So this is the Wallarm UI. I'll point out a couple of things here. So first of all, you are welcome to come look at this demo data yourself. You can go to playground.wallarm.com. You'll get the same interface that I'm using for the demo. It will be read-only, so you can't make any changes, but it will give you the same experience, and you can click through and see what you'd like. The other thing to point out is that our documentation is open. So if you go to docs.wallarm.com, you can read about what Wallarm does and look up the details of the capabilities that we have. So you can sort of combine the playground and the documentation to get a pretty full experience of what Wallarm is capable of. So I'm going to start the demo with an external viewpoint. This is our API attack surface management capability. And so this is an option in Wallarm, a capability in Wallarm that doesn't require that you actually deploy anything to analyze traffic. You simply provide us with some domain names, could be 3 of them, could be 300 of them, and we use those domain names to go out and assess your external API attack surface. So we look for active hosts, and on those hosts, we look for APIs, and if we find APIs, we tell you what kind of API they are, what type they are. And so if you scroll through this interface, you'll see a number of different hosts. I'll try and pick one that is reasonably interesting. Let's try this one here. So here's an example. API 4 is the host. We have 2 APIs on here, a JSON RPC API and an XML RPC API. And of course, in order to find those APIs, we have to tell you what ports are open as well. On those ports, if we can identify an API gateway, we will do so and tell you what it is. In this case, it's MuleSoft. We'll also identify a security vendor that's protecting these APIs. In this case, it's Cloudflare. So most of those security vendors, they're going to be web application firewalls or WAPs, if you like that term as well. So we'll identify those. And then we actually test the security vendor to see what types of attacks they let through and they block. So this tool that we're using for the WAP score evaluation is actually an open source tool that we maintain called GoTest WAF. It's integrated into the product, but if you wanted to use it yourself, you certainly could. You can find it in GitHub. You can Google for it. But we show you this summary here of what types of attacks were let through, how it scored. In this case, Cloudflare as configured on this host. And it didn't do that well in this case, but you'll see if you scroll through, you get different scores depending on the assets that you're looking at. And if you want to see all the details, every test case that we sent and the response we got back, you can click that View Report button, and it will give you a PDF report that provides all of those details, including all the individual test cases that went through. So there's a lot of detail to dig into there if you'd like to. So that's the detailed level of each host, the APIs that we find for that external API discovery. We do provide a summary up at the top of what we found. So overall security posture, what security vendors we found, which data centers these APIs are hosted in, what countries they're hosted in. You can drill into those. And then we also assess and scan those APIs for security issues. So you can see the security issues listed here. I'm going to move over to the security issues interface and show you the list. There's some summary data at the top, of course. You can do some filtering and searching. But you'll find what you might expect from a vulnerability scanning tool here. So if you drill in, you're going to get information, which host was affected, what CVE ID. There's information about, whether the exploit exists, whether it has a high EPSS score. Description will also give you exploitation examples. We'll show you the full request and response that we got back as well. So you can really dive into the details of each vulnerability. There is one security issue that I want to filter for and highlight in particular, which are API leaks. So we also look for leaked sensitive data related to those domains that you provided. And we do that by looking at, sort of a web application or a web property itself, but also looking at public Postman collections and GitHub repositories. So this first one here is an example of an API key and a secret access key. You can see them noted there on leaks.wallarm.tools. If I click on that response and expand it, you can see that they're just hard-coded into the HTML. So we're pulling those out there. The other examples here are examples from, in this case, Postman. So this is a public Postman collection, not your Postman collection, not your GitHub repository, but a public one, where we found 3 pieces of data. And if we scroll down, we can see that these three values were marked as a password. That's the parameter name. So we pulled them out because they look like they're sensitive, called them passwords, and said, look, we found these passwords associated with your host or your organization in Postman, in a public Postman collection, so that you can do something about those. One of the things you might want to do is apply a virtual patch. If you choose to apply a virtual patch, it creates a specific rule to block the use of those credentials, in this case, in traffic using Wallarm as well. So that's the external viewpoint. Again, that doesn't require that you deploy anything. It's done just with those domain names that you provided. We'll move from there into the traffic analysis-based discovery. So now we're looking at data that was collected by deploying what are called Wallarm filtering nodes. Those filtering nodes sit in traffic or collect traffic. There are lots of ways to do it, but ultimately they're analyzing API traffic, looking for information that contributes to this discovery, but then also detecting and blocking attacks. So you'll see a list of endpoints here. We've got 111 of them in this environment. For each endpoint, we'll show you the host, we'll show you the methods that are supported, we'll show you the endpoint itself. We also provide a risk score. I'm going to sort by risk. So the risk score, the highest risks come to the top. For a demo, that's also useful because the most interesting assets, API endpoints, come to the top. You'll see count for malicious requests, total requests. You'll also see this business flow column. So where possible, we will tag those endpoints with a business flow tag. And you can see the list here. We're identifying, is it an account creation or an account management endpoint, an admin endpoint? Is it an agentic AI endpoint? There are a couple of those in here as well. And you can also manually set those business flows if Wallarm doesn't detect and automatically assign them as well. But it gives you the ability to understand what those API endpoints might be used for. We'll also identify what sensitive data was exposed in that endpoint. So I'm going to drill into one of these. And here you get more details about this endpoint. These are the attributes that contribute to that risk score. So you can change the weights on those attributes. There's a configuration option there. This is a summary of the sensitive data we found, but I'm going to scroll down. For each endpoint, for both the requests and the responses, based on that traffic analysis, we'll pull out all of the headers and parameters that we've seen, and we'll look in the parameter name and the value for that sensitive data match. So credit card data, email, personal name, passport numbers, phone numbers, those might be in those parameters. That's not necessarily bad if that's expected in that endpoint, but we want to point out where sensitive data is flowing in that environment. And you can actually configure the sensitive data we're looking for. So if I come over here to configuration, you can see all of the different types of sensitive data that we look for. You can see the regular expressions and the context words that we're using to identify that sensitive data. You can create your own as well. So you can do that with a regular expression and a set of context words that will be used to look for sensitive data as well. So The other thing that we can do in the discovery component is we can compare what was found to what should be in the environment as explained or dictated by an open API specification. If you want Wallarm to produce open API specs for you, you can, but you can also upload them. And then we'll compare what's in the environment to what's in the spec and find rogue APIs. So there are three types of rogue APIs that we look for. A shadow API is an endpoint that's in the environment but not in the specification. An orphan API endpoint is one that's in the specification, but we don't see any traffic for it in the environment. And then a zombie API is one that's been removed from the specification, but stays in the environment. So we'll look for all of those, and you can think of that a little bit as API governance, right? We're trying to make sure that what's deployed in your environment actually matches what's in the specification. So that's a high level of the API discovery capabilities. There's one more thing that you can do with those specifications that's worth mentioning. So I clicked on API specifications. I have a specific specification that's uploaded here. I can also choose to enforce that specification. So if you have an environment where your specification is well maintained and you shouldn't see any traffic that's outside of that spec, you can actually choose to have Wallarm just block anything that doesn't match the specification. So think of that as a positive security model. You're only letting through known good requests as opposed to blocking requests that are detected to be bad. You can choose to block or monitor if you want. You can define specific policies to enforce. If you want to block any request to an endpoint that's not in the spec or requests that have an undefined parameter or are missing a required parameter, you can make those choices. You can also filter that specification enforcement to a specific URL if you want. So if you really want to do specification enforcement only on specific API endpoints, you can do that as well. So the bookend to that positive security model, that API spec enforcement, if you will, is blocking known attacks. So we'll move over here to the attacks interface. And now we're looking at a list of all of the attacks that we've detected, in this case today. There are lots of ways to search and filter this interface, but we're just going to take a look at the attacks that we have here. When I talk about attacks, it's useful to think of them in sort of two big categories or two buckets. There are stateless attacks, which are things that we can detect in a single request. It doesn't require any information about what's happening, in the session or in the whole interaction. It's just that one request. So cross-site scripting is a good example. Remote code execution is a good example. I always like to pull out a SQL injection if I can, because they're often easy to understand. But path traversal is a good example as well. So in this case, we've picked an attack. There are 17 requests that are part of this attack. So we group requests into an attack. We'll show you a little histogram of when those requests were made, and we'll show you the list of all of the requests. You can see that they were blocked, each request blocked. And when we block a request, by default, we issue a 403 status code. You can customize that if you like. And then for each of those, we show you the full request that was tagged as an attack, and we show you the payload, and then you can go find that payload in the request itself. Interestingly, this is actually a request to a GraphQL endpoint, and I did see some GraphQL attacks up here that are worth mentioning. If you're using GraphQL, this is potentially interesting to you. You can set up in Wallarm essentially GraphQL policies. So first of all, we'll detect and parse GraphQL requests. We'll look for attacks in those requests, but you can also set up some policies around things like query depth or batched queries, maximum number of batch queries. You can block introspection or block debug queries as well. So you can get that policy in place, and then we'll block those attacks, or rather those violations of policy, if you will, around GraphQL, in addition to the attacks that you might see. So fairly extensive GraphQL capabilities there. So that was an example of a stateless attack that occurs in a single request. I'm going to go ahead and filter this list now for what we call API abuse. So the other category of attack are stateful attacks, those that are require that we understand what's happening across a session in order to determine that the behavior is suspicious or malicious. So it's no longer a single request. It's now a session that we're actually detecting as abusive. So I'll pick one here. This is an account takeover. And you'll see that we're no longer showing you a list of requests. We're now showing you a summary of that session. And this is where our artificial intelligence or machine learning detection comes into play. So we're looking at sessions and we're setting a baseline of what's normal for those sessions across a variety of different parameters or detectors, as we call them. And then we're looking for anomalies. And you can see the list of detectors here that were anomalous for this particular session: authentication abuse, business logic, request rate, etc. And we'll show you the normal value for this application, and we'll show you the value for this session. And this collection of detectors basically adds up to an account takeover attack. That's a good way to think about it. So you get this summary view of the detection event that occurred, identifying the session as an account takeover. But if you want more detail, you can actually drill into the session itself. So we clicked on that Explore the Session button, and it moved us over to this API Sessions interface with a default, with a filter added for that specific session. And now I can actually see all of the requests that occurred in that session. And I can actually, if I wanted to load them all, I could go through every single one, but I can follow what the attacker was doing request by request. I can drill into those. And in here, I see information that I've chosen to collect. So we're not collecting the entire request and response for every single API request that we see. We collect the entire request for attacks, but we only request what you actually collect, what you actually ask us to request to collect for the requests in general. And in this case, we've defined how to track a session. This one's not very interesting because it's the default, which is a combination of user agent and remote address, IP address. But if you go to the configuration dialog here, you can see that you can choose to tell the system how to identify a session. Is it, the session ID um, header, or I think we've got uh, yeah, jot tokens in here as well. So you can have multiple. And you can also tell us which parameters you want us to request to collect from all of those sessions as well, so that they get displayed in here. And if I remove this filter that was applied, now we're seeing all of the sessions that are present. And you can see requests and attacks. So this had 60 requests and 5 attacks. I can come down here to one that has no attacks as an example. And here I've got a session that in which we didn't detect any attacks. And if I scroll down to the bottom, I've loaded all those requests. I can see that it starts with a login and then goes to this notes endpoint and then a specific note, posts a note and then a specific note. And all of these requests were 200 OK. So this session looks pretty benign. Because it started with a login, I can see we can collect a user as well. And if I wanted to, I can come up here and filter example.com. And now I can see all of the sessions associated with that user. User one doesn't seem to be up to too much trouble, although there are a couple attacks in this one. Start to see a pattern here as you go through the demo environment. And so you can investigate the sessions based on user. You can investigate them based on attacks. There's lots of available detail in there to understand what happened in a given session and understand the context of what occurred before and after a specific attack as well. So pretty powerful tools in terms of attack detection. So that's the basics of the attack detection. There's one other type of attack that I want to make sure that we identify, and that's our credential stuffing detection. In fact, I'll start with the let's start with the configuration for credential stuffing. So we looked at API abuse and we looked at an account takeover attack. So if there's a pattern of API traffic that looks like someone is trying to take over accounts, we're going to detect that behaviorally. But if you're a smart attacker, you're going to change your tactics. You're going to do sort of low and slow. If you've got this big database of known compromised credentials, you're going to do low and slow attempts to try and avoid detection. With Wallarm, you can identify those authentication endpoints. We'll recommend them, and then you can monitor them for specific credential stuffing attacks. So this is the configuration screen, but if we go back to attacks, we can look for credential stuffing. And now we're looking at attacks where a user attempted to log in, attempted to authenticate with a compromised credential, a credential that's in a database of known compromised credentials. And so it only takes one of those and will identify that particular request as a credential stuffing attack. And what that does is it allows you to identify those low and slow attacks. It also allows you to identify legitimate users who are attempting to log in with a credential that's known to be compromised. So I might just not know that my credential has been compromised. I try and log into your application. You'll get an alert that that user has uh, a compromised credential, and then you can choose what to do with that. And we'll take a quick look at the integrations, but you can integrate to your application to either issue a password reset or disable that account if you'd like. So that credential stuffing attack detection is fairly unique detection capability within Wallarm. So from there, let's take a look at some of the security controls and capabilities to actually take some action here. In Wallarm, there are rules and there are triggers. Rules are give you the ability to change detection, essentially. So if you want to, this is actually where you would add the GraphQL policy, for example, but this was also where you could do rate limiting. You can change some of the behavior around detection. You can mask sensitive data. So if you have a parameter that you don't want to show up in the UI, you can choose to mask that. So there are different ways to adjust how the rules process traffic itself. The rate limiting is worth a particular mention because you can rate limit on just about any parameter in the request itself. There's a lot of flexibility around that rate limiting capability. The triggers are really the alerting mechanism or what to do with in terms of response. So you can create triggers for a variety of different conditions. For example, there's the compromised user account trigger. So if you want, you can take a compromised user account, you can filter it based on, application domain response status, and then you can generate alerts to a variety of different integrated systems based on that compromised user account event occurring. There is a generic webhook as well that you can use there as well. And so there are other options for triggers. You can set up a brute force trigger. So a number of requests from the same IP, more than a certain number in a certain time frame can generate that event as well as a trigger. And then, you can see the other ones: forced browsing, number of attacks. If an IP changes in the IP, that's from the changes in the API, sorry, that's from the API discovery, for example. If a rogue API is detected as well. So different options with the triggers there. And then IP lists is another blocking capability. So I mentioned blocking individual requests. So if we see an attack, we can block that request. You can also choose to respond by blocking an IP address for a period of time, or you can block an IP address simply by adding it to the deny list if you'd like. So if we look at here, you can add IPs or subnets. You can block based on location. So if you want to block specific geographies, you can do that as well. And you can block based on source type. So if you want to block a specific data center, maybe you don't expect any of your users to come to your application from AWS, and so you might as well block it. There's also the option here to block Tor exit nodes and known malicious IP addresses as well. And so you can set up that blocking or that allow list behavior from there, and you can also have that as a response in a trigger as well. And then last but not least, in terms of capabilities, I want to cover our API security testing capability. So we talked a little bit about vulnerability detection, which occurs in that API attack surface management interface that you saw. We also have this capability called threat replay testing. So this is not sort of traditional sort of DAST-like API security testing. What we're actually doing with threat replay testing is we're taking attacks that we see targeting a production system and replaying them against a non-production system to find out if it's vulnerable. So the way to illustrate that is through the test policy. You identify or label the host affected by an attack, and then you identify or label the host that you would like that attack replayed on. And so the idea here is that you can detect and block attacks against your production APIs but you still want to know if your APIs are vulnerable to those attacks. So you can replay the same types of attacks on a staging or a test instance that's the same application or API and find out if it's actually vulnerable. And in that way, you don't put your production system at risk, but you still get to test based on the attacks that you're actually seeing in production. And so you can see the history here of where attacks were replayed, if there was a vulnerability found, and the list of vulnerabilities here as well. So we found a few vulnerabilities in this environment, and of course you can drill into those. So that's the API security testing capability called threat replay testing. And I'll wrap up the demo here with a look at the dashboards that we have available. There are 4 dashboards. We've got one built around the OWASP API top 10. So this gives you information about how you've configured Wallarm to protect yourself from the OWASP API top 10 and shows you where you can make changes to improve that coverage. And if you click on those, it will take you over to those places in the UI. There's a NIST cybersecurity framework dashboard that's very similar in terms of telling you how you're configured in relation to the NIST cybersecurity framework. And then we also have an API discovery dashboard, which gives you a summary of that API discovery information that we were looking at. So we looked at the details. Now we're looking at the dashboard, sort of a high level, view of the endpoints discovered, rogue APIs discovered, sensitive data discovered. And then last but not least is our threat prevention dashboard, which is an interesting one because it shows you the flow of traffic and detected malicious requests. So along the bottom here, you've got the traffic processed. Along the top, you've got hits, as we call them, or malicious requests that we detected. And if a malicious request is targeted at a vulnerability that we know about, we'll call that an incident and highlight it as a red dot. Generally speaking, in our demo environment, the percentage of hits to traffic processed is very high, but it gives us good data to look at. You also have a map with attack sources, the most attacked targets, different attack types, the protocols that are being used in the attacks, the authentication being used in the attacks as well. So lots of good information in that dashboard. So with that, that brings us to the end of the demo. Hopefully there was lots of interesting information in there. I'm going to take a look at the questions now and see if I can get through answering them. It looks like there are some questions. So we'll start with the Q&A here. Is Wallarm effective in protecting APIs built using GraphQL or gRPC, not just REST? Yes, absolutely. So we saw an example of GraphQL. I don't think there's an example of gRPC in this demo environment, but we absolutely detect and block attacks for using gRPC as well. You can include SOAP and WebSockets in there as well, so support across the board for those protocols. How does Wallarm differentiate between benign AI activity and malicious automated behavior? So that's where we look at I'll actually pull up a view here for API abuse. So this is where we're looking at our API abuse capability. And I mentioned these detectors. This is the full list of detectors, which are basically individually targeted, trained ML algorithms to look for anomalies in a specific aspect of the traffic. So request rate, suspicious behavior, et cetera, et cetera. And if you click on the little tooltip here, it gives you an explanation and it gives you the statistics for the last 24 hours as well. So it shows you what it's looking at. But it's the combination of these detectors that adds up to malicious behavior. So a single detector doesn't necessarily match. It has to be sort of a combination that indicates that there's something malicious going on. All right, let's see. There's some great questions here, so I'm thrilled. I love it when people ask questions. We've got, can Wallarm detect drift in API schema usage patterns, overuse of optional fields or abnormal field nesting, and alert on potential abuse by automated clients or bots? I'm not sure I understand that question entirely. We would detect drift in. We'll detect if using the specification comparison, you can detect if the production deployed in APIs are different from what's specified. And we'll detect changes in the API itself. So in API discovery, let's see, you can see there are some of these that are flagged as changed. So when parameters or headers are changed in the API, we'll detect those. So the answer should be yes there. I believe that's good. Uh, let's see. How does Wallarm validate conformance of live traffic against OpenAPI specs in real time, and how does it handle partial or version specs? So the the detection of the comparison of live traffic to OpenAPI specs is done by uploading a specification, um, and we'll take whatever specification you upload. So if you upload a partial spec, unless it's invalid, if you upload a partial spec, we'll use that. You can upload multiple specifications. You can also point us to a URL, and we'll keep it up to date as well. And then we compare what we see in the live traffic to that specification, um, and that's how we do that. And if you we do that for two reasons, as I mentioned, either to detect rogue APIs or to block requests that don't match the specification, or monitor. You can set it in monitoring mode, so we'll alert on them, but not actually block them as well. Do you have visibility on the found sensitive data? For example, if it's a password, do you know what it is exactly? No. And this is important, actually. Wallarm is built around this, what I call a privacy first architecture. Because we're designed to be inline, we're really focused on making decisions, in real time on those filtering nodes. We're not building a giant data lake of all of your requests and responses and then doing analysis on them after the fact. So when we're looking for sensitive data patterns, we're identifying that that pattern exists. We're communicating back to the Wallarm console that the pattern exists, but we're not moving the sensitive data itself around. So if there's a password or a credit card number or whatever sensitive data that is, it's never leaving that filtering node. It's not being communicated back to the Wallarm console and being stored there in some way that creates any risk. But we do identify the sensitive data and the type of sensitive data uh, that that was detected. Let's see. Do you support multi-version API governance and can it enforce different security postures per version? So you can upload multiple versions of a spec and it will track what's changed. That's how we do the zombie endpoint detection. In other words, an API endpoint was removed from the spec but stayed in the environment. That's the extent to which we support that multi-versioning currently. Do you support multi-tenancy? Yes, actually, Wallarm is a multi-tenant application. So if you're a large organization or an MSSP, and you want to have a primary tenant with subtenants, you can do that. And the individuals in the subtenants can't log into the other tenants. They have separate installations. So yeah, multi-tenancy is definitely supported. Uh, can Wallarm build behavioral session fingerprints over time by correlating patterns like IP, user agent, TLS fingerprinting, endpoint access sequences? I think that the closest answer to yes on that is the API abuse prevention, which I was just describing before. That's where we're building baselines and looking for anomalies, and we do look at um, some of those attributes as part of that. So um, you can also, I mentioned it before, you can also choose how we identify sessions. So if you want to identify sessions based on specific parameters, you can do that as well. Let's see. I'm starting to pick and choose some of these now. Uh, does your platform support real-time API inventory updates and notify on structural or behavioral API changes? Yep. So the inventory is kept up to date based on the traffic analysis, and if you want to alert on changes, you can set up a trigger to alert on changes. Can the system group APIs by sensitivity, tenant, or business function automatically? So I showed the business flow identification. That's the identification of what the purpose of that is. As a customer or a user, you can group APIs into applications. So these uh, these items over here, default API sessions, notes API, vulnerable AI agent, those are applications, and that grouping is done automatically. You configure it, and then it's done automatically. Let's see. All right, there are a ton of questions in here. I suspect I probably won't get to all of them, but I'll do my best. Uh, are attack detections correlated with known vulnerabilities, CVEs? Yep. So if you look in let's see. oops, sorry, in the attacks interface, there is a filter for CVEs, so you can actually filter by CVE. The attacks are correlated to CVEs there. Let's see. Do you offer parameter-specific fuzz testing? Uh, no. So the testing, as I said, the testing is that threat replay testing. There are some new testing capabilities coming, so keep an eye out. We'll be introducing some new testing capabilities in the next month or so, and the answer to that question may change. But in the current product, it's that threat replay testing. I saw one in here. Are there some use cases for CI/CD direct integrations for API security? That's a great question. Um, Most of the time when people are talking about CI/CD integrations, they're talking about testing, and what they're looking for is the ability to test APIs before they're deployed as part of the CI/CD platform. As I mentioned, what we have today is that threat replay testing that's focused more on using production data, production attacks to test non-production systems. But we do have some new features for testing coming soon, and we can revisit that question when they're released. Let's see. Does the platform offer actual proof of concept execution? Uh, so, as I said, for attacks that we detect, we show you the full request. For vulnerabilities, if we're still talking about those vulnerabilities, we do show exploitation examples. And the format of those examples it varies depending on the vulnerability. In this case, it's a curl command. So it does show you how that vulnerability could be exploited. Uh, can Wallarm support and guide organizations on how to effectively allocate resources, tools, training that specifically address API security? Yes, we can. We would be happy to do that. We've got a couple of different offerings on how we can help, but that's definitely a yes for sure. Let's see. That's another question about fuzzing. So we'll skip that one because we answered it. Which deployment modes do you support? That's a great one for me to answer with the documentation, actually. So in our documentation, there are deployment options listed. There are a lot of them, so you can take a look. We have a fully hosted SaaS offering called Security Edge. That's the simplest deployment option. You just redirect DNS and to us, and then we process the traffic that way. But you can also deploy inside of Kubernetes. You can deploy into the public clouds. You can deploy with a number of connectors. So if you're using an API gateway or Cloudflare or Akamai, we can hook into those to deploy as well, and a number of others. There are standalone inline deployments as a container. There's some out of band options. If you don't want the blocking, you just want the traffic analysis, you can deploy that way as well. And then there are a few custom deployment options that we support as well. So there are many, many deployment options. They're all in that documentation, which is a great place to look as well. All right. And I think there's still some questions in here I could look at. Uh, How does your platform minimize false positives during runtime monitoring or active testing? So I'll point to the documentation again. There is some explanation in the documentation of our specific detection methodologies, but it's essentially a proprietary detection mechanism that's designed to allow to reduce false positives and avoid the need for creating rules and tuning. And there is an explanation in our documentation, which I probably can't find fast enough while I'm on the webinar, but maybe I can. No. Yeah, this detection procedure link is the best explanation of specifically how we avoid false positives and what we do for detection, uh, 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 sort of uh, publicly. So I'd recommend reading that for the detailed answer. How is risk calculated per API tenant threat class? Is it visualized for prioritization? So the risk calculation is done per endpoint. That's the in API discovery. So you see the risk score here, as I mentioned, and it's calculated per endpoint. And there is some customization to the risk scoring. You can choose the calculation method, and you can adjust the weights on each of the criteria that are used to calculate that risk. So there is a customization capability there as well. And I think we're headed towards the end of the questions at this point. And I don't know if everybody's hung around for all the questions. It looks like people have. That's good. Uh, let's see if there are any last questions. Yep, here's a good question to end on. Would it be possible to schedule a more personalized demo session following the webinar to explore features tailored to our specific needs? That's a great question. Absolutely, yes. You can feel free to reach out to us to schedule a demo. There's a lovely Get a Demo button right on the front page of our website, and fill in that form, and we would be happy to do a tailored demo. Generally speaking, we'd love to know what you're looking for in that demo, and then we can build a specific demo scenario for what you're looking for in particular. And I think with that, we're going to call it uh, the end of the webinar. I'll take a look through the questions on LinkedIn and see if there are some that we want to answer in text if I missed any. Hopefully I got to most of the questions, but I want to thank everyone for spending the time. Um, I think it's always fun to do a demo and see the product and, learn a little bit about it. So hopefully that was interesting and helpful for you as well. And thank you for spending time with us.